James Webb just detected something older than the Big Bang. NASA scientists are panicking. The universe may not have begun the way we thought. These are real headlines, real thumbnails, real videos pulling in millions of views across YouTube, TikTok, and Instagram. Faces frozen in shock, red arrows pointing at blurry galaxies, words like impossible, forbidden, rewriting reality flashing across your screen. And the moment you hear it, a single question hits you like a punch to the chest. If the Big Bang created time itself, how could anything be older than it? Think about that for a second. The Big Bang isn't just the birth of stars or galaxies, it's the origin of space, time, cause and effect. According to everything we know about physics, there is no before the Big Bang in the normal sense of the word. So when you hear claims like this, it doesn't just sound surprising, it sounds impossible. And yet, these videos keep spreading. Millions of views, millions of comments, people arguing, people are panicking, people are convinced that NASA has discovered something they're afraid to admit. Some say the James Webb Space Telescope has seen galaxies that shouldn't exist. Others claim it's looking back before time itself. And a few go even further, saying the universe may be far older than scientists have told us. Here's the problem. Almost none of these viral clips explain what James Webb actually saw. They don't explain how astronomers measure time, and they definitely don't explain where science ends and speculation begins. So we're left with confusion, a feeling that something is being hidden. Maybe reality itself is starting to crack. But what if the truth isn't disappointing? What if it's not boring? What if it's actually more mind-blowing than the clickbait? By the end of this video, you'll know exactly what the James Webb Space Telescope discovered, what scientists are genuinely surprised by, what they're not saying at all, and why none of this means something older than the Big Bang was found. And once you understand it, the universe won't feel smaller. It will feel far stranger and far more incredible than you were ever led to believe. What the Big Bang actually means, and what it doesn't. To understand why the claim older than the Big Bang is such a big deal, we need to slow down and get one thing absolutely clear: what the Big Bang actually means. A lot of people imagine the Big Bang as a massive explosion that happened at some point in empty space, like a cosmic bomb going off, but that picture is wrong. The Big Bang was not an explosion in space, it was the expansion of space itself, everywhere at once. There was no center, no edge, and no pre-existing emptiness waiting for it to happen. When cosmologists talk about the Big Bang, they're describing the moment when the universe was incredibly hot, dense, and compact, and then began expanding. As space expanded, it cooled, allowing particles, atoms, stars, and eventually galaxies to form. This expansion is still happening today. Galaxies aren't flying through space away from a central blast. Space itself is stretching, carrying galaxies along with it. That distinction matters more than it sounds, because it defines what we mean by the beginning of the universe. Here's the part that really trips people up. According to our best tested models of cosmology, time and space begin together at the Big Bang. Time is not something that existed beforehand, waiting for the universe to appear. It's part of the universe itself. That's why physicists say the phrase "before the Big Bang" doesn't work in the usual sense. It's not that we don't know what happened before, it's that before may not be a meaningful concept at all. A common analogy helps here. Asking what happened before the Big Bang is like asking what's north of the North Pole. North only has meaning once you're on the Earth's surface. In the same way, time only has meaning once the universe exists. When you reach the Big Bang in our current understanding, you're not hitting an event inside time. You're reaching the boundary where time itself begins. This is why scientists are so careful with their words. If something were truly older than the Big Bang, it wouldn't just be surprising, it would shatter modern physics, including general relativity and everything we use to describe the universe's history. And that's exactly why extraordinary claims demand extraordinary evidence, not viral headlines. What James Webb was actually built to do. The James Webb Space Telescope was never designed to break the universe or rewrite the laws of physics. It was built to do something far more precise and far more powerful. Webb is essentially a time machine, not because it can travel through time, but because it can capture light that has been traveling toward us for nearly the entire age of the universe. Every image it takes is a snapshot of the past, sometimes from a time when the first stars and galaxies were just beginning to form. What makes Webb so special is how it sees the universe. Unlike Hubble, which primarily observes visible and ultraviolet light, James Webb is optimized for infrared light. This matters because as the universe expands, light traveling across it gets stretched, shifting from shorter wavelengths into longer, redder ones. The farther back in time the light was emitted, the more it stretched. By the time the earliest galaxy light reaches us, it's no longer visible at all. It's deep in the infrared, invisible to telescopes like Hubble. This is where Webb completely changes the game. Its massive gold-coated mirror and ultra-sensitive infrared instruments allow it to detect incredibly faint, red-shifted light that no telescope before it could see. That means Webb isn't discovering objects that suddenly appeared out of nowhere. It's revealing objects that were always there, hidden beyond the limits of our previous technology. It's peeling back layers of cosmic history that were simply out of reach until now. This is also why comparisons with Hubble matter. Hubble gave us stunning images of mature galaxies and star-forming regions, but Webb goes further into the cosmic past. It sees earlier galaxies, dimmer structures, and far redder light signals from a universe that was still in its infancy. Webb doesn't replace Hubble, it extends the timeline, pushing our view closer to the moment when the first cosmic structures ignited. And this leads to one crucial idea that often gets misunderstood. James Webb doesn't see further in space, it sees further back in time. Every deeper image isn't breaking reality, it's revealing just how much of the universe's earliest story was waiting in the dark, stretched thin by billions of years of cosmic expansion. How redshift really works. To understand how James Webb looks back in time, we need to talk about something called redshift. Imagine light as a wave traveling through space. As the universe expands, space itself stretches, and that stretching pulls on the light moving through it. A simple way to picture this is to imagine a rubber band with waves drawn on it. When you stretch the rubber band, the waves spread farther apart. Light does the same thing as it travels across an expanding universe, shifting toward longer, redder wavelengths. Scientists measure this stretching using a number called redshift, written as Z. The higher the value of Z, the more the light has been stretched and the longer it has been traveling to reach us. A redshift of 0 means the object is nearby, seen almost as it is now. As Z increases, we're seeing the object further back in time. This isn't guesswork, it's a direct measurement of how much the universe has expanded while that light was on its journey. To get a sense of scale, a redshift of about Z equals 1 means we're seeing light that was emitted roughly halfway back through the age of the universe. When we start talking about redshifts of 10 or higher, we're looking at a universe that was incredibly young, only a few 100 million years old. These are the kinds of extreme distances James Webb was built to study, reaching back toward the era when the first galaxies were forming. This is where confusion often creeps in. A high redshift does not mean an object is older than the universe. It means the light we're seeing was emitted a very long time ago. The object itself formed after the Big Bang, existed within time, and evolved as the universe expanded. Redshift is a clock for light travel, not a loophole that lets us see beyond the beginning of time. This leads to the key idea that cuts through most of the viral misunderstanding. Redshift tells us when the light was emitted, not that the object existed before time. James Webb isn't peering into a forbidden era before the universe began. It's capturing the earliest chapters of cosmic history that were always there, just stretched too thin and too red for us to see until now. The oldest galaxies ever seen. One of the most jaw-dropping discoveries made by the James Webb Space Telescope is the detection of some of the most distant galaxies ever observed, with estimated redshifts around 13 to 14. These numbers aren't just technical details, they represent light that has been traveling for over 13 billion years. When that light left these galaxies, the universe was still in its infancy, barely beginning to organize itself into stars, galaxies, and structure. When astronomers translate those redshift values into time, the results are staggering. These galaxies are being seen as they were roughly 280 to 330 million years after the Big Bang. To put that in perspective, the universe today is about 13.8 billion years old. That means these galaxies formed during the cosmic dawn, an era when the first stars were switching on and the universe was transitioning from darkness to light. What truly surprised scientists wasn't just that these galaxies exist so early, it was how they look. Some appear brighter, more massive, and more evolved than models had predicted for such an early time. According to earlier theories, galaxies in this era were expected to be small, chaotic, and slow to assemble. Instead, Webb revealed systems that seem to have formed stars rapidly and efficiently, growing faster than expected in the young universe. This does not mean the Big Bang is wrong or that the universe behaved impossibly. It means our models of how quickly matter collapses into stars and galaxies need refinement. The laws of physics still hold, gravity still works the same way, but the timeline of early galaxy formation appears more aggressive than previously assumed, forcing scientists to update simulations and rethink how fast cosmic structure can emerge. This is the crucial distinction that gets lost in viral headlines. These galaxies are not older than the universe. They did not exist before time began. They formed after the Big Bang, within the rules of physics, during the earliest stages of cosmic history. What changed wasn't the beginning, it was our understanding of how quickly the universe learned to build complexity. And this is where the real wonder lies. The universe didn't break the rules, it just played them faster than we expected. James Webb didn't uncover an impossible past. It revealed a universe that was far more efficient, energetic, and creative in its earliest moments than we ever imagined. Little red dots, early black holes, and cosmic mysteries. As James Webb pushed deeper into the early universe, astronomers began noticing something strange scattered across its images. Faint, compact objects that appeared unusually red, small, and intense. These objects quickly became known as little red dots. At first glance, they didn't behave like typical young galaxies, and they didn't fit neatly into existing categories. They were too bright for their size and too common to ignore, making them one of the most intriguing surprises of Webb's early observations. One leading explanation is that many of these little red dots may be early active galactic nuclei galaxies whose centers are dominated by rapidly growing supermassive black holes. As matter falls into a black hole, it heats up and emits enormous amounts of energy, often outshining the stars in the galaxy itself. In the early universe, this process could make relatively small systems appear unusually bright and red in infrared light, exactly the kind of signal Webb is designed to detect. Another possibility is that these objects represent an early phase of black hole growth that scientists have never directly observed before. One of the biggest open questions in cosmology is how supermassive black holes formed so quickly after the Big Bang. Some of the little red dots may be evidence that black holes were growing far more rapidly in the early universe than previously thought, feeding on dense reservoirs of gas and reaching enormous masses in a surprisingly short time. What's important is that scientists are very open about what they don't know yet. These objects are still being studied, debated, and modeled. New data from Webb and other observatories will be needed to confirm what they are and how they formed. But uncertainty here does not mean something impossible or unphysical is happening. It means the universe is revealing a phase of its history that was always there, just beyond our previous ability to observe. This is where popular narratives often go wrong. When scientists say something is mysterious, they don't mean it's magical or beyond explanation. They mean the investigation is still unfolding. Mystery does not mean magic, it means discovery in progress. James Webb hasn't uncovered a cosmic contradiction. It has opened a new chapter that astronomers are only beginning to read: supernovae, gamma-ray bursts, and early stellar death. One of the most exciting revelations from the James Webb Space Telescope is its ability to detect the earliest stellar explosions in the universe. Among these is a supernova associated with a gamma-ray burst that occurred roughly 730 million years after the Big Bang. This event represents one of the earliest known deaths of massive stars, giving astronomers a window into the violent processes that shaped the young cosmos. The importance of observing such early supernovae cannot be overstated. Stars are the factories of the universe, forging elements heavier than hydrogen and helium in their cores. When these massive stars reach the end of their lives and explode, they scatter these elements into space, seeding future generations of stars, planets, and eventually life. Detecting a supernova this early shows that the universe began producing heavy elements far sooner than some models had assumed. Gamma-ray bursts, the intense flashes of energy often linked to supernovae, add another layer of intrigue. These bursts are among the most powerful explosions in the universe, briefly outshining entire galaxies. Finding them in the early universe confirms that massive stars not only formed quickly, but also ended their lives in spectacular energetic events. This paints a picture of a young cosmos universe that was dynamic, violent, and full of activity within just a few 100 million years of the Big Bang. Observations like these also tie directly into our understanding of structure formation. Supernovae and gamma-ray bursts help regulate the growth of galaxies by distributing energy and material throughout the interstellar medium. Their early presence supports the idea that galaxies could evolve rapidly, forming stars and complex structures much faster than we once thought. Webb's discoveries of these early explosions reinforce the evidence that the universe was already an active, structured place at astonishingly young ages. These findings remind us that the early universe was far from quiet. Stars lived fast, died young, and dramatically reshaped their surroundings. Far from being theoretical, these cosmic fireworks provide tangible proof of the speed and intensity with which the cosmos built itself, setting the stage for everything we see today. How clickbait warps real science. If you've been scrolling through social media, it's easy to see how the story of James Webb detecting something older than the Big Bang went viral. Headlines are designed to shock, to make you click, and to make the impossible sound real. They often distort the facts, mixing real discoveries with misleading interpretations, creating a sense that science itself has gone haywire. But the truth is far more nuanced and far more fascinating. One common tactic is the misuse of the word before. Some videos claim that certain galaxies or cosmic objects existed before the Big Bang. In reality, astronomers are talking about light that was emitted very early in the universe's history, sometimes just a few 100 million years after time began. Saying before the Big Bang is not just inaccurate, it completely changes the meaning of the discovery, turning careful science into clickbait. Another tactic is ignoring the language of uncertainty. Scientists are careful to qualify their statements, using phrases like may indicate, potentially, or consistent with models. Influencers often remove this nuance, turning cautious suggestions into definitive claims. A galaxy that is surprisingly bright for its age becomes impossible according to science, which is simply not true. The contrast between how scientists communicate and how influencers present the news is stark. Astronomers talk about probabilities, measurements, and models. They publish peer-reviewed papers full of data, charts, and careful reasoning. Social media clips skip the data and go straight for emotional shock. This isn't just misleading, it's a fundamental distortion of how science works. Understanding this difference is key. Science is not about drama or viral attention. It advances through careful observation, repeated verification, and cautious interpretation. Bold thumbnails and over-the-top claims may grab attention, but they don't change the underlying facts. The discoveries made by Webb are extraordinary. On their own terms, they don't need exaggeration to be awe-inspiring. So the next time you see a headline claiming the universe is older than time or that NASA is hiding something, pause and remember, viral excitement is not the same as scientific evidence. The real story of Webb is more subtle, more precise, and ultimately more mind-blowing than any clickbait can convey. Science advances through careful doubt, not bold thumbnails. Could anything exist before the Big Bang? Even though James Webb has taken us closer to the beginning of time than ever before, it cannot show us what, if anything, came before the Big Bang. That question moves into the realm of theoretical physics, where scientists explore models that extend beyond our current observations. Among these are ideas from quantum gravity, which attempt to unite general relativity with quantum mechanics to explain the very first moments of the universe. These equations suggest that the Big Bang might not be a singular starting point, but rather part of a more complex structure. Another intriguing possibility comes from cyclic or bouncing universe models. These propose that the universe may go through endless cycles of expansion and contraction, with each Big Bang emerging from the collapse of a previous universe. If true, it would radically change our understanding of cosmic beginnings. However, these ideas remain highly speculative and, importantly, there is currently no observational evidence supporting them. Webb's observations, as groundbreaking as they are, do not provide any data on prior cycles or pre-Big Bang events. Cosmic inflation also raises questions about what might have existed before the observable universe. Inflation describes a brief period of exponential expansion that set the stage for the Big Bang as we know it. Some inflationary models suggest that multiple pocket universes could exist, each with its own physics. While fascinating, these remain hypothetical constructs. No telescope, including Webb, can yet detect other universes, and any claims to the contrary are purely speculative. It's essential to emphasize the boundary between theory and observation. Theoretical physics is a playground for the imagination, constrained only by the requirement of mathematical consistency. Observational astronomy, on the other hand, is grounded in measurable light, spectra, and redshifts. James Webb excels at the latter, revealing galaxies and cosmic structures from the first few 100 million years of the universe. It does not and cannot reveal anything before the origin of time itself. So while we can dream and calculate about pre-Big Bang possibilities, we must keep them in perspective. These are equations on paper, not things James Webb has seen. The telescope brings the universe's earliest chapters into view, but the prologue that might exist beyond time remains entirely theoretical, waiting for future ideas and experiments to explore. After everything we've explored, here's the truth. James Webb has not detected anything older than the Big Bang. Time itself began with the Big Bang, and all of the galaxies, stars, and cosmic fireworks Webb is observing formed after that. The laws of physics remain intact, and our understanding of the universe's origins still stands. What makes Webb's discoveries so extraordinary is the glimpse it provides into cosmic dawn. For the first time, we can see galaxies as they were just a few 100 million years after the Big Bang, witnessing the very first stars switch on, the first galaxies ignite, and the universe slowly light up from darkness. We are watching the universe learn to shine. Every red-shifted photon, every faint glow from a distant galaxy tells a story of rapid growth, early structure formation, and cosmic creativity that challenges our models but not our physics. These are discoveries that inspire awe, wonder, and curiosity about the vast cosmos we call home. And so, the final takeaway is clear. James Webb didn't rewrite the beginning of time. It showed us how fast the universe learned to shine. By observing the earliest chapters of cosmic history, we are reminded that even in the universe's infancy, complexity, light, and life-giving elements were already being built. If this journey through the cosmic dawn has sparked your curiosity, keep asking questions, exploring space news, and following real science. The universe is full of mysteries waiting to be discovered, and James Webb is only the beginning. Stay curious, stay inspired, and let the stars guide your imagination.